Hello everybody, welcome to MSDOSX, lecture number 14 this time. Where I'm going to talk about, today I'm going to talk a little more specifically about iOS events and drawing and views. I'm going to do a really super fast, as if last time wasn't fast enough, I'm going to try and do a really super fast refresher on how points and areas and rectangles and views and everything are represented for OS 10 and for iOS and the comparison between the two. I also fixed up a few of the slides that were a little unclear about NS and UI responder. We'll talk about that as we get there. So, as a reminder, NS, all of the NS prefixed objects come from Foundation or Cocoa classes. The CG prefixed objects come from core graphics, which are usable for both OS 10 and for iOS. The NS specific stuff is Cocoa and OS 10. There's differences between they're very similar, but there's a significant difference. Hopefully you saw last time, and I'll reiterate it as we get to it this time. So NS point, as a reminder, two floating point values, an X and a Y. It's a C structure. It's not an object. CG points, same thing, two floats and an X and a Y. Both of them have a constant, either CG point 0 or NS 0 point. As a reminder, you make these structures for under Cocoa with NS make and the name of the object. So NS make point, NS make rect, NS make size. CG core graphics is CG the object type and then the verb. So CG rect make, CG size make, CG point make. NS points, if you recall, lower left is 0, 0. That's the origin. X is positive on the right axis, to the right on the x-axis, up positive on the y-axis. So this is point 1540. CG points start in the upper left. Point 0 origin is up here. It's also positive X on the right axis, but it's down on the y-axis for positive values. So this is point 1540 in core graphics, in the core graphics coordinate system. So that's 1540 in NS, 1540 in CG. That's incorrect, and I'll fix that. NS sizes, remember, contain two floating point values as well, a width and a height. You make these with, just as I said before, NS make size. CG sizes, same thing, two floats, width and a height. You make these with CG size make. NS rectangles, NS recs are made up of a point and a size. So they're made up of an origin and a size. They're no longer left, right, top, bottom, but a pair of points for an X and a Y and a pair of sizes for a width and a height. NS make rect takes all four parameters and gives you back that structure as a value. CG rect, same thing. Have a CG point as an origin and a CG size as a width and its height. So NS rectangles, origin lower left, positive X is the width, and positive Y is the height for rectangle size. NS rectangle size height. Positive on the y-axis. CG rectangles, on the other hand, origin is in the upper left, still positive X for the width on the right, but it's positive. It's down for positive height on the y-axis. They're C structures, not Objective-C classes. You don't use the asterisks for them unless you are, say, allocating and creating 1,000 of them in memory, and you want to reference them by pointer. They're all passed to. They're all passed in Objective-C or Cocoa and iOS. They're all passed by value, not by pointer. There's also, obviously, since they're not Objective-C classes, no need to retain or release them. Views are, so, and a little bit of clarification from last time. So NSUI responder is kind of the overarching superclass for a lot of these objects that respond to user interaction. They're responsible for handling events and have all the infrastructure for handling an event. As an example, NS and UI views subclass off of NS and UI responder, respectively. Further subclassing, buttons and text fields are subclasses of NS, UI, or UI views. So these are all in a big chain that go up to the parent class of NS UI responders, which have the parent of NS or UI or NS objects up above. So typically you subclass the NS or UI view controller to implement your event handling. You'll see in the lab, and I also, this just comes from legacy, and I need to break myself of this habit, put these in the view. You're able to do that, you're allowed to do that, you're allowed to put event handling in the view. However, it's not very good form, especially doesn't fit very well in the MVC design pattern. So typically you subclass, in your subclass for your NS view controller or UI view controller is where you handle events, where you put your overridden methods for event handling. And we'll talk a little bit, I'll review a little bit more of the event handling here in a moment. NS and UI views are just subclasses or classes that you typically subclass when you need to do custom drawing. NS and UI views can also contain subviews within them. So there's a whole hierarchy that goes to NS and UI views. So in this example, this is an NS window, OS X. This is an NS window. It's got a box view, it's got a text field, and it's got a label. This NS Windows content view is this view, which has a box and a text field and a label. This content view has subviews of this box and this label. These are both NS views as well. This box subview has got a text field subview as well. So it's all one big hierarchy, and it's all maintained that way. The window manager maintains it that way, so it knows where to send events to appropriately. Frames and bounds are a common source of confusion, like I said last time, for specifying the sizes of NS views and UI views. Here's the difference. Frames are for specifying within the super view where your rectangle, where your view should be located. Your bounds you can specify arbitrarily to specify the scale, the width and the height of, and the scale of where points should be in relation to your frame. Oftentimes it's one-to-one, but I'll show you an example where it's not. So once again, frame is the coordinates, the rectangle, origin and size within the super views frame. The bounds are the boundaries that you want specified for that frame. So as an example, here's a super view. Here the frame is an NS rect. We're making it starting it at 1515, and its width is 40, its height is 30. So this is now our origin for this frame. Here's the super view. For this frame, here's the origin in the lower left. Remember, NS recs have an origin in the lower left. Our boundaries that we're going to set for this frame are going to be one-to-one with the size of this frame. So we're going to say the boundaries here are 0, 0, and with the width of 40 and a height of 30 pixels. So we have a one-to-one pixel correspondent between where we want to draw or where we want points associated with to our frame. We can change that if we want to. Here we have the exact same frame specified in our super view at 1515, 4030 for its width and its height. However, we've set the bounds to be 0, 0 in the lower left and 1, comma 1 in the upper right. So this would be this point right here would be 0.5, 0.5 in using our bounds. Does that make sense? So you can, yes.
This is pretty much like scaling, right? If we give it a 1 to 1, then it's...
Exactly. You can actually do a lot more, even more powerful things than scale. You can scale and translate and rotate, and we'll talk a lot more about that when we talk some more about core graphics, the underlying stuff. That is one of that was the impetus for part of this, was not only the resolution independence, but also making it a lot easier for the programmer to deal with different files that had images and had different resolutions.
It's also nice in cases where, for example, it's convenient for you to have the center be 0, the center of your view be 0, 0. If you reassign the bounds, then you can assign it in such a way that the center of your view is 0, 0, and that often makes your drawing code easier if you have some sort of rotational symmetry that you want.
So in terms of this frame that we've set up here, if we set our bounds to start at -20, -15, and the size was 40, 30, we could have 0, 0 be the center of this frame. If we drew at 0, 0, this is where it would draw to. Does that make sense? Drawing drawing. If you have custom drawing that you need to do, you do it in an overridden method in your views. It's in your either NS view or your UI views. When you subclass them, you override drawRect is the name of the method. It doesn't return anything. It takes as input a NSRect or UIRect in the case of an iOS application. That rectangle specifies what needs to be redrawn at that time. So in the past, if you covered up a portion of your window and then you uncovered it, you would get called your drawRect method would be called with that portion that was uncovered, so that you only had to refresh just that portion that was uncovered. You didn't have to redraw your whole window, especially if that was an expensive operation. You'll typically get at your program startup, you'll get a call of drawRect with the rectangle specifying the bounds of your frame to refresh or redraw your whole window. You saw in the Bouncy lab, and you'll also see it in the Sudoku lab. If you work on the homework, you'll see that you actually can have your screen, your display redrawn at specific intervals, on a timer or on according to an event. However, you don't call drawRect yourself. You don't ever invoke it explicitly yourself. The way that you do it is you tell your view that you need to be redisplayed. And if just calling it with setNeedsDisplay yes means send it the entire bounds, and drawRect will be called with the entire bounds, and you can refresh the entire view. If you only need to redisplay a portion, say you're working on optimization or working on some kind of performance, that you need some performance enhancement, you can pass setNeedsDisplay in rect. You can pass a specific rectangle, and your drawRect will be called with just that specific rectangle. It's all timed so that it works in conjunction with the window manager, so that things aren't getting drawn out of sequence. Let's say if there's a window in front of you, you aren't ever allowed to draw over the top of that of some other application's window that may be in front of you. There is a way to short circuit this setNeedsDisplay to no. That I will let you explore on your own.
Yeah, interestingly, on iOS, the setNeedsDisplay method doesn't take a parameter. It's just it's an implied yes.
Good point. I will add that to this slide. So what Kevin was saying was that this is for an NS view. For a UI view, it's just setNeedsDisplay. You don't pass it a rectangle, and you don't pass it a CGRect. It just assumes that you're refreshing the entire view.
Well, no, it has setNeedsDisplay in a rect, but the setNeedsDisplay method, there isn't one that takes a Boolean parameter.
Gotcha. Okay. Does that make sense? So this is there in iOS and OS 10. This one, the iOS version, just assumes that you're saying, yes, I need to be redisplayed. There's legacy reasons for being able to turn that to short circuit and say, okay, no, I don't need to be redisplayed at this time. So events. So an NS or UI application is the overarching object that manages what's called the run loop in your application. It's constantly running, constantly looking for events, and constantly dispatching them to the correct views or the correct responders, actually, I should say. You say, for instance, wait for events from the mouse or the keyboard on the Mac, or wait for touches under iOS. The events are dispatched to the relevant objects that are all subclassed off of NS Responder or UI Responder with OS 10 and iOS respectively. If you recall what I review back to what I said originally, all NS views and subviews, all of these things are subclassed off of NS Responder and UI Responder. So they're all capable of handling events in sequence, in order. The NS or UI application is the file owner of mainmenu.nib or mainwindow.zip. The typical application life cycle, just kind of the 1,000-mile up view. Your application starts, the main menu or main window zip loads. Then your run loop just starts and keeps going. There's things that happen with memory management, as you've seen with the auto release tools and things. For the purposes now, you don't have to. We're not really concerned about that. What we're more concerned about is responding to events, receiving events, and having them dispatched correctly to the correct responder, whether it's a view or a subview of a view or a text field of a subview of a view. As soon as your application decides that it's ready to quit, or the OS wants to shut you down, and your application terminates and you don't receive any more events. So some of the kinds of events that you get on the Mac on OS 10 are the mouse button being pressed or dragged or coming up, the mouse being moved, the keyboard being pressed, input tablets. The Magic Mouse has trackpad support. So there's a lot of different types of events that can come in that are special for OS 10 or for Mac as opposed to iOS. So typically, the way that events are dispatched under the hood, the NS application receives from the window manager, receives an event, whether it's let's say in this case the mouse is being pressed. It figures out which window your mouse is hovering over the top of, and if it's even your application that's in the foreground to begin with. If it's not, it'll bring your application to the foreground, eat the mouse click, and then will respond to mouse. Your application will respond to mouse clicks from then on out. If your application is in the foreground and you click the mouse, an event is sent through the responder chain to figure out which window your application has in front that should respond to the click. The window then finds the appropriate, the view is then found within the appropriate window using this method called hit test on the content view of the window. This is all under the hood stuff that you don't necessarily need to be concerned with unless you're trying to do some very specific event handling. If you are, there's a lot of reading reference on this. I just wanted to give you kind of an overview of what's happening under the hood. And it's not just simple mouse press and you get a mouse event. There's actually a lot of things that are going on. And there's a lot of things you can customize too, which is pretty cool. So mouse events for OS 10 depend on the type of event. The examples when these slides were made were the mouse being down, the mouse coming up, the mouse being dragged from one location to another, the mouse just moving, the mouse entering the location, and entering a window, and the mouse exiting a window or a view. So here's an example of handling a mouse event. So this is the kind of the general template for the mouse handling, mouse event handler. Doesn't return anything, and it takes one parameter, an NS event object. That NS event object, if you look in the documentation, there's a lot of methods that the NS event supports. One of those methods is location in Windows. So you can find out whatever event it was, a keyboard event or a mouse press event or a tablet event, whatever. You can figure out where in the window this event happened. Because you've set bounds and because you've got your own frames and subviews and subviews of subviews and subviews of subviews in this whole hierarchy and all of these different coordinate systems, you need to have some easy way to be able to translate a screen coordinate to a window coordinate to a specific place in your view. Here's an example of doing that. Converting the self is referring to the view, the view or the view controller that contains a view. Convert point is the method, and you give it back this window position that came from the event. You can also specify which view it came from. I'll leave that as an exercise for you to take a look and see how that can actually be useful for you. In this case, what we're really concerned with is where in the view was the mouse clicked. Actually, we're not even so concerned with that at this point. We can just ask the event how many times the mouse was clicked, and if it was clicked twice, according to the user preferences, system preferences, then we know that we've had an actual double click. It wasn't too long, it wasn't too short or too fast. That the event is able to basically package all of this information up and tell you, yes, you have a double click at this point, and this is where you can handle it. You can also get the change in mouse location from event to event, so you can ask where the delta in X or Y coordinates, and so in a sense you can do your own drag handling. If you look, there is an event mouse drag that will let you know the start and end points, but you can also handle that yourself. Say if you want to do something different with a double click drag or a triple click drag, you have complete control over that, and all that information comes from the event, NS event. For keyboard events are handled a little bit differently, because instead of clicking on a window and specifying a coordinate system within a window, Windows and Windows NS app and UI app have what's called a key window, which is the window that's going to be accepting keyboard input. That goes further down the chain in that it's actually an NS responder that is the first responder to keyboard events, and since that can be NS responder is the superclass of a view or a text box or a scroll box or any number of different UI objects, you can make a lot of these things respond to keyboard presses and be the first to respond to keyboard presses too. I'll talk about that in a second when we talk about the first responder. Actually, let's talk about that right now. Let's write down the slide. So you can there's a chain. There's a very set chain of who responds to what event. If you get a keyboard event, internally there's a chain for who gets to respond to that key. If you don't respond to it, it just goes up the chain. It just goes up the view hierarchy until somebody responds to it, and then that keyboard event is cleared, and it waits for another event to come in. You can say that, okay, yes, this window is the first responder, and you'll see this in the Sudoku lab. You'll see that you can set the window as a first responder. You can also do this with iOS with text fields. And when you call up views, you can set a specific text field to be the initial responder for a keyboard. And I believe the keypad automatically pops up when you set a text field or something to be the first responder, right? view for your NS view, and I believe the UI views as well, you need to be able to be set as the first responder for OS 10 or iOS. To allow you to be the first responder, you override this method called accept first responder, and you say yes or you say no, that I'm not allowed to be brought forward and accept key presses, or yes, I am allowed to be brought forward. I'm allowed to even be brought forward right now as the application starts up and make me the very first one to respond to keyboard events. 2 keyboard events for an NS responder are key up and key down, pretty obvious. So the event has you can query the event for the characters that were currently pressed when the event occurred. You can also ask for the modifiers that are currently being held down at the same time. Control, Option, Command, Shift, and Function. I think I got them all. You can check you can check the command. You can check the key mask, the NS key mask or the UI key mask, to figure out to see what modifier keys that you can intercept or that you can test for to see if they're down or not. In this case, what we've done is we've masked off the command key, and we're checking to see if the key down is equal to an S, and if it is, then we've held the command key down and hit S. Typically, that's handled by OS 10 as being a save option or save event. But you can override that if you want to, or you can do any special handling that you need to do of a document before you save. This is a way that you can do that. You can intercept this event first. So iOS specifics. So they don't have keyboard and mouse events per se. They have touch events instead. A UI event contains a collection of touches, and I'll talk more about that in a second on the next slide. Multi-touch support is a Boolean that you can turn on or off. Your application can actually be set to respond to multi-touches or to not respond to multi-touches. So touch events look like this. Are there still 4? Mm-hmm. So here are the 4. Touches began, touches moved, touches ended, and touches canceled. These are the 4 main events. Here's what the template for them are. You get a set of touches. Does everybody remember what a set is? The NS collection set. What's special about it? Objects within it, unique or duplicate? Unique only, yes, good. And then a UI event is the other parameter that comes past. So it's touches begin with event, touches moved with event, touches ended with event, and so touches and event come in. I'll show you a specific event here in a second. Touches began is pretty obvious. Touches moved is as you're sliding, as you're moving, you can actually track touches as they're coming in. Touches ended is either when you've taken you've stopped the touches manually, or have they distinguished this now with touches canceled? So if you get interrupted with a notification,
there's kind of touches canceled is kind of touches ended is pretty obvious. It's when the finger comes up. Touches canceled usually gets called in sort of some esoteric situations. It's either when, for example, the user gets a phone call or a text message, and all of a sudden your control of the UI is lost, so therefore your touch doesn't make any sense anymore. The other time that happens is, for example, if you have a view inside of a scroll view, that view inside the scroll view might want to listen for touches. Since UI can't right away know if a touch is going to result in a scroll or not, it will send a touches began, but then if you discover, oh, actually I'm starting to scroll, and so it'll scroll the scroll view, which means that we didn't really want to touch the view inside, that view will get a canceled, because that touch was not meant for it was meant for the scroll view.
So the bottom line for touches canceled is that you should have logic in there that you should be able to gracefully handle when a touch has began and that you've started processing a touch, but then a touch is canceled, and you should be able to restore state from there. Getting a touch is canceled instead of a touch is ended shouldn't put your iOS app in a funky state. It should be able to recover from that gracefully.
Generally speaking, what that means is if you allocate any resources in began, you need to get rid of them in ended and canceled, because either one of those could end the event.
So here's an example with touches began. Touches began with event. So if you query the event here and ask for all the touches, it returns every one of the touches during a multi-touch sequence. So if you have a began, a move, and an ended, you can get every single one of those touch locations from the event. The touches that's passed in here are the touches that are associated with just that one event. So if you get down to touches ended, the touches that comes in here will be where the fingers have come off the screen, for instance. But you can still say, all right, I want to know all of the touches since this chain of events began, from where the fingers went down to where they moved to where they came back up. So it's a way that you can distinguish between the two. Sorry.
Not really. The distinction, if you're only dealing with one finger, they're actually going to be in the same set. If there's only single touch, it's going to be the same set. The difference is if there's multiple touches. So basically, the all touches is the set of all touches that are currently down. But the touches parameter are just the ones that happen. So you can imagine that I have 3 of my fingers held down, and then I let go of one. So I'm going to get a touch as ended because I had a touch that ended. So that single touch will get passed in as the touches set. But the event still has 3 touches involved, because there's 2 still left, and then the one that came off.
Yes, and we will put a lab together to elaborate this at a future date, because that's pretty key. There's a lot of really good documentation on this in the Apple Docs that help to elucidate this quite a bit. And actually provide some diagrams and things that I didn't want to dive into here. If you're only expecting to get one touch back, if you disabled multi-touch and you're only expecting to get one touch back, touches any object is a perfectly valid way to say, okay, give me just a single touch that I'm looking for, even if it's got multiple touches in it, which it shouldn't if you've got multi-touch set correctly. Touches any object will give you back a valid object according to that event. Here's an example of parsing a touch event. So in this case, we're not multi-touch enabled. We've got touches any object is going to give us back where the touch happened. If we can query the touch for the number of times that it was tapped, the finger was tapped on the screen, and we can handle a double tap here. We can also say, okay, give us the previous location of where our finger was before and where our finger is now, and find out where we dragged from and to, all coming from this single touch event. Turning on multi-touch is pretty simple. In your awake from nib, in your view, awake from nib, all you need to do is set the property, set multiple touch enabled, set it to yes, and you'll start receiving multiple touch events.
Yeah, and really you can do that whenever you want. It's just a property on view that you can set.
And resources. Some more places to read. So these slides will be up in just a second. Already are. So the homework is the lab and the homework are available. I want to give you a quick. One of the homework options is to add a computer player to the Sudoku game. This is here's an example of that. So you're actually able to play this live against the computer. So that's one of your options for homework, is adding a computer player, which is another view controller. You can also have some fun with it and make the computer play really, really super fast, and you can't possibly beat it.
Oh, man.
Done! But all that's up on the website. Did you want to say something?
It just randomly picks numbers until it finds
Magic.
nothing. I realized it gave a lot of wrong answers. Actually, does it backtrack then? Like, does it have a stack and then it just does like a word search?
If I give away all my secrets,
For the drag events, like, does it give one every pixel or every, like, how does it decide when to fire off the drag event?
which
It's not super well defined. I believe it's going to depend on the screen's refresh rate, which is typically 30 hertz.
So it'll, like, give
So
you that-
you're not guaranteed that they're going to be that they're going to be on adjacent pixels. If you're swiping really fast, they might be two adjacent ones, but two subsequent calls might be far apart.
the way that you can handle that though is collect relative locations off of the previous event and the current location. You can actually collect all of those, and those are guaranteed to be correct. Even if you're not getting like updates 30 times a second, the overall relative distances will be correct. Does that make sense?
Yeah, but also that also means that I can have hundreds or thousands of those events.
Yeah, typically you get those events very, very rapidly.
So I don't want to ever parse it myself.
Depends on what you want to do with that.
You can do rather a lot of computation in there and not see a performance hit.
Okay. Also, the computer, like, how do you play against a computer? Is it who solves it faster? Or
Yeah, it's who solves it faster. So you've got, so it's going through and it's playing right now.